Hello, and welcome to your first functions lecture. So functions are something that you might already be a little bit familiar with. They take some input, perform some action, and then usually give you some output. You may have encountered functions in math or some other similar field, but we can also use functions in programming. Now, why would we use functions? Things have been going smoothly without them, so why introduce them at all? Well, for a couple reasons. The first reason is they help us split our code into small, manageable pieces. Once you start writing code that's a little more complicated than the things that we've been writing in class, it's really helpful to have those codes in manageable chunks that you can look at and say, okay, I know that this chunk does this thing and that chunk does that thing. It also helps our human brains understand code better. For example, if we have a function that gets a user input, maybe their name, stores that and makes sure that it's clean, strips all the white space, etc., it can be really helpful to just be able to see a line of code that says get user name instead of seeing all of the lines of code that it would require to actually do that action. Next, it actually makes our code neater. There's often going to be times where we want to do the same thing or at least a similar thing over and over, and functions are a part of what help us do that. And finally, functions are a great way to share your code with others. For instance, we've been using a lot of functions like the math.square function that other people have written for us that do something more complicated and allow us to use that code in our own code. The syntax for defining a function is going to use the def keyword. So we're going to say def, short for define, the name of the function that we'd like to use, and then parentheses and a colon. Indented underneath that def, we're going to have all of the code that's going to execute when we call the function eventually. Last but not least, a function can, but doesn't have to, have a return statement. So functions can get much more complicated than this, but this is at least the very basics. Now let's go to Atom to see how we can define a function in Python. Okay, so let's write a very simple function. Remember that the keyword def is what tells Python that you would like to define a function. And then we're going to say the name of the function. So I'm going to say name printer because I'm going to do a hello world function. And this is going to take in an argument. An argument is essentially something that can change every time that you call your function. In this case, the argument is representing the name of the person that we would like to greet with this function. The way that you set up an argument is by putting it inside the parentheses, and you can think of this argument as a variable name that we're going to use throughout the function when referencing this object. Lastly, on this line, I'm going to add a colon, and then I'm going to indent. Indentation tells us what code is part of this function and what code is just part of the script that we're writing in general. So in this case, I'm going to say print hello plus whatever the person puts as their name. Now notice this function does not have a return statement. Functions don't have to have return statements, although they often will, and in a second we'll build some that do. But in this case, our function just prints out hello and the name that we give the function. This is really helpful because we can use this same function to greet multiple people. We can give it one name like John, and then Jane, and then Julie. Any name that we give it, our function can reuse the same code to greet that person. Let's practice our function definition syntax and define def, the squared function. Now, we already know how to do this just in regular Python, but we're going to write a function that squares a number. The argument that's going to go into this is the number that we'd want to square, and I'm just going to call it n. Again, I'm going to end this line with some colons, and then I'm going to indent underneath to say what code is part of the function. I'm going to say return n times n. In other words, return n squared. Now remember, the argument n is just a variable that references whatever number we give to this squared function. It could be 2, it could be 12, it could be 17.4. Whatever it is equal to, we can reference it by using the variable name n inside the function. So if you give me 3 for n, then it's going to say, well, return 3 times 3. Now this return statement means instead of printing out something for the user to see, we're just doing a computation that we can then store later on for our use. There are two main parts to building and using functions in Python. First, we have to define the function, and that's what we've been doing so far with our def statements. The next thing that we have to do is invoke or call our function. When you write a function definition using that def statement and all of the code that goes under that, you are telling Python what you would like it to do when you call the function, but you're not actually asking it to do anything yet. You can think of this as giving someone a recipe for your favorite chocolate chip cookies, but you haven't actually asked them to bake them for you. Calling the function is when we actually ask Python to perform all of the instructions we told it to do in the def statement. In other words, we are asking Python to use that code just like we could ask our friend to actually bake the cookies. They had the instructions before, but now we're actually asking them to do it. You can define a Python function anywhere in your script that you would like to. However, just like how we have to import packages before we use them, we have to define our own functions before we use them. So as a rule, while you can define them anywhere in your script as long as it's before you use it, we typically will put all of our function definitions at the top of the script. That just saves us a lot of headaches because if you define it at the top of the script, it's almost impossible for you to call a function before you've defined it. To demonstrate some of the things that I just talked about, let's quickly comment out this top code and then run just our name printer function definition. So I'm going to go ahead and save and Python 3 and functions 13 blank. Beautiful. Now notice that when we ran our code, nothing outputted, and that's even with the fact that we have this beautiful print statement in our function. Well, that's because we defined the function, we gave Python the instructions for what we would like it to do when we call nameprinter, but we didn't actually call it yet. That's why it didn't print anything, because we didn't ask it to. If we wanted it to print, we would have to actually call the function. We can do that by saying the name of the function that we would like to call, and then giving it any arguments that it requires. In this case, we just require a name, so I'm going to say Chelsea, and let's go ahead and save. Now when we run this, you can see that it'll actually call the function and perform the actions inside that nameprinter function. In fact, it prints out hello Chelsea. All right, let's write a couple more functions. So we're going to say def name printer 2, and we are going to again have an argument name. So we're going to ask it to give us a name as a string, but this time I would like it to give both a first and a last name. Since we have both a first and a last name, I'm going to split those up using the .split method that we learned in the last lecture. I'm going to say names equals name.split. And by default, it's going to split on spaces, which is exactly what we want. Because for instance, if I put Chelsea space Parlette, the space is what separates my first and my last name. Next, instead of just printing hello and then first name, we are going to print out their last name, comma, their first name. So we're going to say print names, and we're going to grab the second element at index 1, plus a comma and a space, plus names 0. So this is going to say grab their last name, put a comma, grab their first name. All right, let's go ahead and save that, comment this out. Now, if we ran everything just like this, nothing would print out. Again, we've given Python the instructions for what to do, but we have not asked it to actually do anything yet. To do that, we need to call our function, and we do that by saying the name of the function, underscore printer 2, and then give it an argument for what name should be. In this case, I'll say Chelsea space Parlette. All right, let's go ahead and run this now that something will actually print out. So we can go ahead and run, and you can see we get Parlette, comma, and then my first name, Chelsea. Next, before we do any more functions, I want to talk a little bit about namespaces. So you can think of namespaces as basically rooms or planets or somewhere where all of the information that we're creating and defining in our script is stored. When you call a function, our script basically pauses where it is, creates a new little room, and runs the function in that room and waits for the output. Basically, you can think of this as a function kind of has its own little world where it's running, and then when it's done, it comes back to the main world or the main room where we were running our script. However, this has a really interesting effect on what happens to variables that we define or create inside of a function. You can basically think of a function as Vegas. What happens in a function stays in the function unless we specifically ask it to return something to us. Remember, what's happening inside of our function, all that code that we wrote for our function, is happening in a local namespace, which means that everything that you create is going to stay in that namespace and is not going to come back with you into your regular script namespace unless you ask it to. The way we ask Python to take something from that little function namespace and bring it back into our regular global one is with a return statement. Now, a return statement is basically a function stopper. A return says, okay, I am done. You don't need to run anything else. Just take whatever we're returning, bring it back to our main script, and that's it. This means that we can only have one return statement because as soon as we see a return statement, the function's over. This also means that any code that happens after your return statement is not going to run at all. Let's go to Atom to see some examples of this. Okay, so let's look a little bit about that namespaces thing that I was talking about. So let's create a variable x and set it equal to 5. Then we're going to define a function called add1, and it's going to take in a number n. And all we're going to do is say x equals n plus 1. Then we're going to print x is, and then what the current value of x is. Now notice, we have a variable x that we've created here in our script, and it's equal to 5. Inside our function, we also are creating and reassigning a variable called x, and it's going to be set to whatever our function takes in plus 1. But let's look what happens when we actually do this in our script. So first, let's say print x is, and then x. So this is going to tell us before we've even run our function, what is the value of x. We're expecting it to be 5 because we haven't really done anything to it yet. Next, I'm going to call add1 and put x as the argument input. Finally, once the function is done running, let's print out what x is again to check if it changed. We'll say x is x. So the phrase x is should print 3 times. Once before the function is run, once during the function, and once after the function is done running. Let's see what happens. Okay, so we can see, as expected, the first x is was 5, and that makes sense because we haven't done anything yet and we assigned x to be 5. Next, inside the function, we printed x is 6 because x was whatever x was plus 1. However, once that function is done running, that reassignment of x to be equal to 6 is gone. When we print x is after the function is done running, x is still 5. This is a product of that namespaces thing that I was talking about. What happened in the function stayed in the function. X was 5 before, and it's 5 after. Only inside that function namespace, which is when we printed this, is when x was 6. All other times, x remained unchanged because it happened in the function's namespace, not in our global one. Now, that might seem kind of inconvenient to you because when we call functions, we want it to do something. We don't want it to just like forget everything that it did. And that's where the return statement comes in. So I've gone ahead and copied our code from before here, and we're going to add one thing. And that one thing is a return statement. We're going to return the value of x that we've calculated inside of our function. The next thing that we have to add is an assignment. So when we return something from a function, that means that we can set a variable equal to the output of that function. So if we want to store the updated value of x, we know it's not going to happen by default because of the function namespace. However, we can do it as a return. So we can say x equals add1x. This is basically saying, well, x was whatever it was before. Now I want it to be equal to whatever the result was that was returned from the add1 function. So now let's go ahead and save and run and see what happens to x. Great, so the first two outputs are exactly the same as the first time. Before we do anything, x is 5. Inside the function, once we've added 1, x is 6. Now, however, the difference is that because we've set x equal to the output, whatever came in the return statement, we have now set x to 6 even outside of the function. So again, a return statement is a way to take something that we created inside the function namespace and bring it back into our global namespace. This only works if you actually store it somewhere, but it's definitely a way that we can grab things from our function and bring them back to our global namespace. All right, let's write another function. We're going to say def greater than 10. And this function is going to take in an argument n, which is going to be a number. And this function is going to return true if a number is greater than 10 and false if it is not. So I'm going to say if n is greater than 10, return true. Else, return false. Now, you might be saying, wait a second, you just told me that I can only have one return statement. You have two, what the heck? Well, what's happening here is that we do have two return statements in our code. However, it's impossible for both of them to run. When I said you can only have one return statement, what I meant was you can only have one return statement run. You can't have two return statements that you expect to both run. However, in this case, either we're going to come to return true, end the function, or if n is not greater than 10, we'll come to this return and return false. So it's okay to have two return statements, like 2 lines or multiple lines of return statements. What's not okay is to expect that you would have multiple return statements running at one time. So again, if we ran this script as is, nothing would happen because we've defined the greater than 10 function, but we have not called it. If we wanted it to actually do something, we could say print and then say greater than 10. So we're calling the function and we'll test it out with 16. And when we run this, we get the output true because 16 is indeed greater than 10. Because we have a return statement, if we wanted to assign a variable to be the output of this, we could. So we could say gt for greater than equals the output of greater than 10. We can totally do that as well. And then we could say print gt. Remember, returning something doesn't mean you've stored it. If you want to store something that's returned from a function, you actually have to do that assignment in Python. But we can see when we run this, it runs exactly the same way, except now gt has been stored so that we can use it later on in our script if we would like to. Okay, last but not least, let's write the adventure mess function. We are going to pretend that we're writing an adventure game, and part of that game is going to be printing out messages that an adventurer says. And so this function is going to take in a string that's a message that we want the adventurer to say. But if you've played any text-based video games, you know that we have to prepend that message with the adventurer's name. So we're going to say def adventure mess, and this is going to take in a message. Call that message. And then inside the function, we're simply going to say print adventure, did I spell that right? There we go, colon, space, and then add the message so that when we print this out, it'll look like it should in a text game where it says the name of the person saying something and then the message that they want to say. Again, if we ran this as is, nothing would run because we've defined the function, but we have not called it. To call it, we're going to go ahead and say adventure mess and then give it a message. We'll say, I'm so excited to go on an adventure. Beautiful. Let's comment out our old code and then run this. And here you can see that our function has indeed done exactly what we would like it to do. It printed out adventure, the name of the person speaking, and then it printed out the message so that it looks kind of how you would expect in a text-based video game. All right, that's all I have for you. See you for more functions next time.